Hey guys, so in this video we're going to be talking about standard position for vectors, the zero vector, and component form. So let's begin with this main question. What does it mean for a vector to be in standard position? Well, you see, a directed line segment whose initial point is the origin, which is 0, 0, is often the most convenient representative of a set of equivalent directed line segments. So this representative of the vector v is what we call in standard position. So a vector whose initial point is at the origin, 0, 0, can be uniquely represented by the coordinates of its terminal point, which we would call v1 and v2, right? So this is the component form of a vector v, right? This is the component form. Except we write it as v equals, we have these little pointy brackets, we would say v1 comma v2, right? And so that's what we call component form, okay? So let's talk a little bit really quick about what the zero vector is before we move into component form, okay? So the coordinates v1 and v2 are the components of vector v. Now, if both the initial point and the terminal points lie at the origin, so what I'm saying here is if v1 was 0 and if v2 here was also a 0, then v is the zero vector, right? And we denote that by a big 0 here equals, and then our pointy brackets, 0, 0, okay? So let's go over that just real quick one more time. So the zero vector is when the initial point and the terminal point lie at the origin, okay? So let's talk a little bit more about this component form, okay? So the component form of a vector with the initial velocity, or sorry, excuse me, the initial point, P, and that's at P1, P2, and has a terminal point at Q. We'll call that Q1 and Q2, is given by the vector PQ equals Q1 minus P1 and Q2 minus P2 equals our vector V1, V2, right? So sometimes this can be really overwhelming, and it can be a little bit easier if we think of this as an X1 and a Y1, and then the Q is an X2 and a Y2, because then we're able to see that all we're really doing here is we're simply just finding the difference of the x's, right? That's all we're doing. We're finding the difference of the x's, and we're finding the difference of the y's, which in turn then makes it really easy for us to think about our magnitude, right? Because remember, magnitude is distance or length, so we're just going to use the distance formula here. So again, all we're doing is finding the change of our x's and squaring it, right? And we're finding the change of the y's and squaring it. Then we're going to add it and square root it. And that's going to give us our magnitude, right? That's going to give us what we need, okay? So if the distance of v, if our magnitude of v equals a 1, then we say that v is a unit vector. Okay, so when our magnitude is 1, v is a unit vector. And if you have that the magnitude of v is 0, that can only happen if v is the vector 0 that we were talking about a little bit earlier. Okay? So that's going to tell you a little bit more about standard position, about the zero vector, and about component form.